Hi, my name is Charese Gates, and today I'll be talking about motion and kinetic equations in the slideshow and video presentation slideshow. When we look of how things move, we have to understand what causes that motion and how we can measure it. This is a topic that has been around since Newton's time, but has been expanded by Einstein and others. We'll look at the basics of velocity and acceleration to how motion works in space and time. So this slide is about motion. Motion is the change in position of an object over time. It might sound simple, but understanding what causes things to move and how to describe the movement is what physics is all about. The quote I got from the textbook says, "All objects tend to maintain their state of rest or straight line, and this property is called inertia." So this slide is about distance and displacement. Distance is how far something travels. Displacement is how far it was from where it started. So if you were to run in a circle and end up in back of the same start, your distance is long, but your displacement is 0. This is important because displacement is used in a lot of formulas in physics. The quote I got from ChatGPT says an object can travel a large distance and still have 0 displacement if it returns to its starting point. Speed. So this one is about speed and velocity. Speed is how fast something is going. Velocity tells us how fast and what direction it was in. I got this quote from Hyuna 2021. It says that it points out that students frequently associate greater velocity with greater force. So even though those are different ideas, it shows how motion and direction are part of how we naturally think about movement. So this slide is about acceleration. Acceleration means that something is speeding up or slowing down. It's a change in velocity. It's a change of velocity. The quote I got from ChatGPT says, "When acceleration is constant, kinetic equations allow motion to be predicted precisely without knowing the initial conditions." So this slide is about the units we use. So we measure distance in meters. Speed is in meters per second, and acceleration is in meters per second squared. These units help scientists and engineers all around the world speak the same language when we talk about motion. The quote I got from ChatGPT says, "Without these standards of measurement, it would be impossible to accurately compare results or communicate scientific data." There are 4 main kinetic equations. These help us calculate things like how far something has moved, how fast it was going, or how long it took to get there. Then another quote I got from Hyuna talks about how students benefit from using these equations with the context of force. It makes more sense of motion. So here are the 4 kinetic equations. So these equations are especially useful when you have a constant acceleration. For example, if a ball is rolling down a hill, these formulas can help you find how far it will go or how fast it was moving after 5 seconds. So here is another reason why the kinetic equations are useful. So here's projectile motion overview. So this slide talks about horizontal and vertical motions, how they're independent. So horizontal motion has a constant velocity, while vertical motion has a constant acceleration due to gravity. There's another quote I got from Hyuna 2021 explains how the students think through these kinds of problems by connecting physical institution with math. So here's another slide about kinematic equations, projectile motion, and classic kinetics. So classic motion is based on Newton's law. It works really well for everyday speeds and objects, but once you get close to the speed of light, Newton's law starts to fall apart. That's when Epstein's theories come in. So relative motion kinematics, So relative motion deals with objects moving close to the speed of light. At these speeds, time slows down and mass increases. Rosenfeld, a quote I got from Rosenfeld, 1982, describes this movement when mass loses its classically identity. So it becomes linked to energy. For classic and relative motion, Rudolph 2004 explains that classic equations are the limit case of the relativistic ones, meaning that they still work but only when speeds are much lower than light. So this slide is about Albert Einstein and his roles. So Albert Einstein changed everything when he showed that space and time are not separate. They are one thing. Space-time. He introduced the idea that time is not constant and that motion affects how time passes. Rosenfeld 1982 said Einstein resecured the concept of mass by showing its deep concentration to energy and motion. So real-world aspects of relativity and motion. Relativity isn't just a theory. It's used in GPS without correcting for the relativistic effects of satellites moving fast and being further from Earth's gravity. GPS wouldn't work. Rudolph 2004 says, the quote I got, reminds us that even though relativistic corrections are small, they're essential for precision systems. So, for the summary, understanding motion helps us understand the universe, from throwing a football to sending rockets to Mars. Hyuna 2001 showed that when students connect equations to real-world thinking, they learn better. That's what physics is all about. And here are my references. Thank you.